All right, thank you for joining me for rational expressions. So this section correlates to section 1.6 from the free online textbook from OpenStax. We're going to simplify, multiply, divide, add and subtract rational expressions in this section. So before we start, I'm going to warn you that this section is heavily based on factoring. So if you have not had a chance to look over 1.5 yet, you really need to do that, because if you are not good at factoring, this is not going to make any sense. You're going to have a really hard time with this section. So the ideas in this section are actually pretty easy. What's difficult is all the factoring. So work through these, make sure you get plenty of practice on these as well. And doing this section will also help strengthen your factoring skills. So once you have a basic understanding of 1.5, you should be able to apply that to this section. So number 1, simplify the rational expression. The first thing you want to do when you're simplifying these is you want to factor the top and the bottom completely so that you can try to cancel out like or common factors. So that's what we're going to do here. So the x squared minus 16, that is a difference of squares. So that's going to factor into x minus 4 and x plus 4. The bottom has 3 terms. It's a trinomial and it has a 1 in front of the x squared. So I'm going to be able to factor that with an x and an x. What multiplies to get positive 4 and adds to get negative 5? Well, that will be a 4 and a 1, and they'll both have to be negative. That will multiply to get positive 4 and add to get negative 5. So now, once it's fully factored, you can cancel out an entire factor with another entire factor. So the x minus 4s are the same, and so you can cross those out. And that would simplify this fraction into x plus 4 over x minus 1. This is in lowest terms. Now, you might be thinking, well, hey, how come I can't just cross out these x's, right? Those x's are a part of the factor. So the x plus 4, the x plus 4 is like bonded together. This is an entire factor. So the plus or the minus symbol bonds those together, and they can only be crossed out if the entire thing can be crossed out. So x plus 4 is considered one thing. It's one factor. The x minus 1 is considered another factor. It's one thing. So since we can't cross out this entire thing because the entire thing is not the same, you're not allowed to cross out just the x's. Okay, so that is why the x plus 4 over x minus 1 is in lowest terms. That's as much as you can cancel out. All right, number 2, multiply the rational expressions and express the product in simplest form. Well, multiplying is basically exactly what we just did. It's just now instead of having one fraction, we have 2. So we want to fully factor all of the numerators and denominators. So for this first numerator, it's a trinomial with a 1 in front of the x squared. So it's going to factor into x and x. And then what multiplies to get negative 6 and adds to get negative 1 will be negative 3 plus 2. So I highly recommend in this section, if you will pause the video and try to factor these yourself, then you can come back and see if you factored them correctly and see what to do after that. But I would strongly recommend that you factor them yourself and then come back to the video. All right, so that's the factoring of the first numerator. Now the bottom, we have a trinomial, but it has a number in front. So here we're going to have to do the AC method. So I'm going to do this one. Let's use red for this. So I'm going to have to come over here and do some side work. So 2x squared plus x minus 6. So I need to know what multiplies to get negative 12 and what adds to get 1. So if I use 4 and negative 3, that will multiply to get negative 12 and add to get 1. So that's going to work. So 2x squared plus 4x minus 3x minus 6. I now need to do factor by grouping. So 2x is in common. That will, when I divide that out, will leave me x plus 2. Bring down the negative. A 3 is in common. When I factor that out, that will leave me x plus 2. So x plus 2, 2x minus 3 is the factoring of that first denominator. Oops. All right. Now we have times the second numerator. That's a trinomial, and it has a number in front. So I'm going to have to do side work for that one as well. So 2x squared plus 7x minus 15. So it's going to be another one like the red. So I need the product to be negative 30 and the sum to be 7. So let's see, 1 and 30, 2 times 15, 3 times 10. Oh, there it is. So I didn't think of it at first, so I just started making a list. So if I do negative 3 and positive 10, that will multiply to get negative 30 and add to get 7. So this is what I'm looking for. So bring down the 2x squared. Then I have minus 3x plus 10x from over here. And then bring down the minus 15. Now I'm going to do factor by grouping. So the x is in common. So that'll leave me 2x minus 3. Bring down the plus. The second two have a 5 in common. So I'm going to divide out a 5 and I'll be left with 2x minus 3. Notice the 2x minus 3's are the same. And then I have x plus 5 left over. So the blue factors into 2x minus 3 times x plus 5. All right, and then the bottom, that's just a difference of squares. So that's going to be x plus 3 and x minus 3. Okay, so that is really the longest part of the problem is factoring. Now that you have it all factored, for a product, you can cancel any numerator with any denominator. So if I look at that, I'm going to have x minus 3 is the same as x minus 3. One's on the top, one's on the bottom, so I can cancel them out. I also have x plus 2 and x plus 2. I can cancel those out. I also have x, let's see, 2x minus 3 and 2x minus 3. Those are the same, so I can cancel those out. Now I've canceled out everything that's alike, so now what I have left on top is x plus 5, and on the bottom I have x plus 3, and that's simplified. This is equivalent to what was given in number 2, so you can see that this is much simpler than what we had originally. Remember, you cannot cross out the x's here because the x's are bonded with the number. It's a full factor. So this is it. All right. Okay, number 3. Dividing fractions. If you remember, when you're dividing fractions, like let's say I have something simple like this. The way you divide fractions is you keep flip change. So you keep this first fraction, you flip the second fraction, and you change to multiplication. So that's what we're going to do here. So we're going to keep the first fraction as is. So 3y squared minus 7y minus 6 over 2y squared minus 3y minus 9. Change to multiplication, and now flip the second fraction. And if you know that that's the same thing, then you can just do what we did in number 2. So you want to rewrite a division problem as a multiplication problem, then fully factor and cancel out common factors. All right, so let's go through the process here. This first one is 3 terms, and there's a number in front of the y squared, so we need to do some side work. Oh, let's see. So we got 3y squared minus 7y minus 6. And I think I mentioned the factoring is what takes the longest in this section. So product is negative 18 and the sum is negative 7. And so if we use negative 9 and positive 2, that'll multiply to negative 18 and add to negative 7. So bring down the 3y squared minus 9y plus 2y from the chart. Bring down the minus 6. Now we're going to factor by grouping. So 3y is in common. So we have y minus 3 left. Bring down the plus. 2 is in common. If we divide out a 2, we'll have y minus 3 left. So y minus 3 and then 3y plus 2. So that's the red. All right, now I'm going to have to factor the bottom. It's the same process, but with different numbers. So if I do that one in blue, I will have 2y squared minus 3y minus 9. So I need the product to be negative 18 and the sum to be negative 3. So if I use negative 6 and 3, negative 6 times 3 is negative 18. The sum is negative 3, so that will work. So bring down 2y squared, then use the minus 6y plus 3y from the chart. Bring down the negative 9. Now we have 4 terms, so we're going to do factor by grouping. So 2y is in common. If I divide that out, I will have y minus 3 left. Plus 3 is in common. If I divide out a 3, I'll have y minus 3 left. So y minus 3 and 2y plus 3 are my factors for the blue. Okay, now I need to do the same process with the third polynomial, or the first numerator. So green, I will have 2y squared plus y minus 3. So I will need the product to be negative 6 and the sum to be 1. So if I use 3 and negative 2, that will multiply to get negative 6 and add to get positive 1. So I will have 2y squared plus 3y minus 2y from the chart minus 3. Factor by grouping. So y, that'll be 2y plus 3. Bring down the negative. There's nothing in common here, so we're going to factor out a negative 1, and that'll be 2y plus 3. Notice what's in parentheses is the same, so 2y plus 3 is one factor, y minus 1 is the other. Okay, and so then the last one, the denominator, is the quicker factoring method. All right, so let's see what we have. We have the red is y minus 3, 3y plus 2. The blue is y minus 3, 2y plus 3 times the green is 2y plus 3 times y minus 1. And then the last denominator, this will be y and y. What multiplies to get negative 2 and adds to get 1, 2 and 1, plus and minus. That will multiply to get negative 2 and add to get 1. Okay, so now that we finally factored everything, we want to cancel out common factors. So y minus 3's, those are the same. I have 2y plus 3, one on top and one on bottom. And then I have y minus 1's, those are the same. And that's it. So what I have left after I cross everything that's alike out is 3y plus 2 over y plus 2. You cannot cancel out these 2's because the 2's are attached to the y's. So it's either all or nothing, remember that. So since I can't cross out the entire factor, this is it. This is in lowest terms. Okay, so now we've done simplifying, multiplying, and dividing. Now we're going to look at adding and subtracting. Usually we think adding and subtracting is easier, but In this section, it's more difficult because remember that you have to have a common denominator. So in number 4, I've given you an example that already has a common denominator, so the bottoms are the same. Remember that what you do is you add and subtract the top, or the numerator, and you leave the denominator alone. So for this one, x plus 3 will go on top, because those are not like terms. All you can do is add them like that. And then the bottom will be the same, x squared minus 9. That's the adding part. Now, remember that when you have fractions, you always try to reduce. So you want to simplify this. So you want to try to factor. The bottom will factor because it's a difference of squares. So the top is x plus 3. The bottom factors into x minus 3, x plus 3. And notice that you do have common factors. If everything from one of the parts cancels out, remember that it's leaving ones in its place. So now what's left on the top is a 1 and an x minus 3 on the bottom. So that is your sum in lowest terms. So when you are given something that already has a common denominator, look for the fact that you might need to simplify. Okay, otherwise it's just too simple. So make sure you're looking to see if you can simplify at the end. Okay, number 5. This is subtraction. We do not have a common denominator. One of the denominators is a 2q and the other one is a 3p. So the first thing we want to do is we want to find a common denominator. To find a common denominator, you want to include each different factor raised to the whatever power you see, the highest power. There are no powers here. So we want to include each different factor. So 2, we have to include a q, we have to include a 3, and we have to include a p. So each of those are different factor. Each of those are multiplied together. So to see what we have, we multiply that completely and we get 6pq. So our least common denominator is 6pq. What we do with that is we want to find out what is missing and multiply by that. So if we compare 2q and we're comparing that to 6pq, what is missing? What do we need to multiply 2q by in order to make it be 6pq? So in order to make the 2 be a 6, we need to multiply by 3. And we have a q, so we need to multiply by the p. So if we multiply the 2q by 3p, we will get 6pq. Remember, whatever you multiply on the bottom, you have to multiply the top by that as well so that it's an equivalent fraction. So this will end up being 36p over 6pq. Minus, now we're going to look at the 3p. What do we need to multiply by to get 6pq? So we have a 3. To get 6, we need to multiply by 2. We already have the p, so we need to multiply by the q. So if we multiply the bottom by 2q, we need to multiply the top by 2q as well. So here we will get 12q over 6pq. Okay, so now that we have a common denominator, we can add or subtract in this case. We will have 36p minus 12q over 6pq. All right, the last step is to make sure that you've simplified. That means you need to factor. In this top, what we can do is we can factor out a common factor. So a common factor is 12. So if we factor out a 12, we will get 3p minus q over 6pq. Now that we have it fully factored, we can cancel out what's alike. Well, the 12 and the 6 aren't exactly alike, but they have something in common. We can divide the 12 by 6 and get 2, and we can divide the 6 by 6 and get 1. The reason we can divide these numbers is because neither of them have a plus or minus. They're not attached to anything, right? It's not 6 plus 2, or 6 plus p. It's not p plus 12. So since they're numbers by themselves, that's why we can divide these numbers or reduce these numbers, because they're factors unto themselves. So now we have 2 times 3p minus q over pq left. We cannot cross out the q's because the top q is attached to the other part by a minus. So this is as far as we can go. Okay, number 6. Let's see. I just want to see how many we have. Okay, we have 8. All right, so number 6, we have a difference. So the first thing we need to do is look to see if they have a common denominator. They do not, so we're going to define our common denominator. So the first denominator has a factor. Look at the plus, right? These are together as one factor, is x plus 1. The second denominator, this is an entire factor, is 2x plus 1. So the LCD is just going to be multiplying those two things together. So if I do that, that means from the first fraction, the denominator has the x plus 1, but it's missing the 2x plus 1. So I need to multiply this one by 2x plus 1. Okay, man, that is messy. Let's try that again. 2x plus 1. Okay, now what I want to do is you're going to FOIL or distribute the top, but the bottom you're going to leave factored. So if I distribute the tops, I'll have 2x times x is 2x squared. 2x times negative 1 is negative 2x. 1 times x is x, and 1 times negative 1 is negative 1. Over the bottom, I'm not going to multiply it out. I'm going to leave it like that. Okay, the second fraction, I have 2x plus 1. I'm missing x plus 1. So I'm going to multiply the top and the bottom by x plus 1. Again, on the top, I'm going to FOIL it or distribute it. And on the bottom, I'm going to leave it factored. So I have 2x times x is 2x squared. 2x times 1 is 2x. 3 times x is 3x. And then 3 times 1 is 3. And on the bottom, I have 2x plus 1 times x plus 1. Notice I have a common denominator. So now I can subtract these two fractions. And the whole reason I went ahead and multiplied these out on the top is because I need to combine all of my like terms. So here, let's see, I have these x terms are like, and here I have these x terms are like. So I'm going to go ahead and combine those first. So 2x squared minus x minus 1 over the LCD minus 2x squared plus 5x plus 3 over the LCD. Okay, now I want to combine the tops. Here is where, if you've gotten this far, here is where you don't want to mess it up. This negative, you're subtracting the entire thing. So the negative needs to be distributed to everything in that following numerator. So this is going to be 2x squared minus x minus 1 minus 2x squared minus 5x minus 3. So I would really suggest taking the time to write this step out and making sure you change all the signs appropriately. Now, you want to combine like terms. 2x squared and a negative 2x squared, those are opposites, so those cancel out. Then you have negative x and negative 5x, that'll give you negative 6x. Negative 1 and negative 3, that's negative 4, over the common denominator. All right, now the last step is to factor the top to see if you can reduce. So the top, they both have a negative and a 2 in common. So I could pull out a negative 2, and that would give me 3x plus 2 over 2x plus 1, x plus 1. I do not have any factors that are the same. So this is as simple as it gets. Okay, so now for the last two examples, these are complex fractions. A complex fraction means you have a fraction within a fraction. What you want to do here, and there are different ways to do these, this is how I would suggest doing them, because all you're doing is using knowledge that you've already talked about in this section. So the first thing I would suggest doing is combining your numerator first. So look at your numerator only. Do any addition or subtraction. All right, so let's do that first. So this is our red step, okay? So if I'm just looking at the numerator, I'm looking at, so this is step 1, 6 over y minus 4 over x. So I need to actually do this subtraction, which means I need to find the LCD. So the LCD in this case is x and y. So I'm going to multiply by whatever's missing. So I need to multiply the first one by x, and the second one, I have the x, I need the y, so I'm going to multiply that one by y. So I will get 6x over xy minus 4y over xy. Now I have a common denominator, so I will have 6x minus 4y over xy. Okay, so this is step 1. That is my numerator. Okay. Now step 2 is look at your denominator only. Do any plus addition or subtraction for the denominator. So let's have this be the blue step. Okay, so I'm going to look at the bottom. The bottom, so step 2, the bottom is just y. There is no addition or subtraction to do here. So that step is done. The third step is write as a division problem. So we'll call this the green step. Remember that a fraction is simply a division problem rewritten. Okay, so this big fraction symbol is going to become a division. So what you're going to do is you're going to write it as numerator divided by denominator. So step 3, my numerator in red, right, is this, 6x plus 4y over xy, divided by my denominator is y over 1. And now you're going to solve that. So your last, let's see, write as a division problem and divide. So you're going to simplify it. All right, so we know to do the division, you actually have to change to multiplication and flip the second fraction. So this will be 6xy plus 4y over xy times 1 over y. Okay, I cannot simplify anything here. I have a plain y down at the bottom on the right-hand side, but there's not just a plain y on the top. This y up here is attached to the 4, which is attached to the 6x with a plus. So you cannot reduce anything here. So you're simply going to multiply straight across. So you'll get 6x plus 4y, because that times 1 is just itself, and then xy squared on the bottom. and that's it. Okay? So that is the steps that you will go through to do these, 7 and 8. Okay, so 8. We want to look at the numerator first. So that is the red step. So first step is the numerator. So A over B minus B over A. So first thing we want to do is find the LCD. Well, that is AB. So we're going to multiply by whatever we need to get that. So the first fraction, all we have is the B. Well, we need it to be AB, so I'm going to multiply by A. The second fraction, I need the B, so I'm going to multiply it by B. So here I will get A squared over AB minus B squared over AB. And so then since I have a common denominator, I can combine those. So A squared minus B squared over AB. And then I want to factor. So this will be A plus B times A minus B, because that's a difference of squares, over AB. All right, so there is the first step. That's my numerator. The second step is looking at the denominator. So I have A plus B over AB. Well, I already have one fraction here. There's nothing to add or subtract. It's already been done. So this is the denominator. All right. Oops, let's get rid of that. Okay, so now for the third step, the green step, we need to write as a division. So it's numerator divided by denominator. So numerator is A plus B times A minus B over AB divided by the denominator, A plus B over AB. Then we want to actually do the division, which means we need to change it to multiplication and flip the second fraction. So the first fraction stays the same. We change to multiply, and we flip this fraction so it becomes AB over A plus B. Now we want to reduce, so we can see that we have A is the same, B is the same, and A plus B is the same. So we have nothing left on the bottom. Remember, that leaves ones. So we have 1 on the bottom, and we have A minus B on the top. Remember that a fraction over 1 should just be simplified to the numerator. So A minus B is the answer to that one.